So today we'll be doing human geography. Human geography, now this portion is going to be very fact heavy because human geography I will not be covering from NCRTs. NCRT human geography, which is class 12, in my opinion, is outdated. Like it will give you a basic understanding of the fundamentals, but it will not help you solve questions from prelims or prelims related paper. So I'm going to focus a lot on that aspect, and which is why it's going to be very fact heavy. So if you need some time to write it down, let me know. I'm not going to explain a lot of the concepts. If you need help with the concepts, then maybe mention it. I can do it briefly and do it quickly. But otherwise, the focus is going to be on a lot of the facts because these facts will help you solve questions. These facts, if you see, will also be the basis of last year's paper. Okay, last year's prelims paper was very fact heavy, very like required you to know, understand trends, understand the basic ballpark figures. Okay, so okay, this one class I'll go slow because it's very fact heavy and you need to make notes. Okay, so so yeah, let's start with population. Human geography, let's start with population. About source for human geography, that's the issue. There is no one good source. There's no single good source. You need to make your own notes. Okay. Human geography, unfortunately, you need to make your own notes, and the notes need to keep evolving. Because the biggest issue with human geography is if I make notes 1 year and I don't update them the next year, they'll become outdated. Because everything changes very quickly. Okay. So let's start. Keep up, write down the facts and figures because these will be helpful. Like I guarantee that when we come to do questions, these will help you solve a lot of those questions. Okay. So first fact is that the first census of India was conducted in 1872. Population, we're doing population now. First census of India was conducted in 1872. First synchronous decennial census. First synchronous decennial census was conducted in 1881. Synchronous decennial census meaning census happened everywhere at the same time, and after that census was repeated every 10 years. So 1881 the census, then 1891, then 1901, 1911, like that. Okay, decennial is like, okay, one second. Synchronous decennial census. Synchronous decennial census. Okay. So the between 2001 and 2011, Indian population grew by 17%. Between 2001 and 2011, Indian population grew by 17%. Between 1991 and 2001, Indian population grew by 21%. So rate of population growth is slowing. Rate of population growth is slowing. Okay. Rate of population growth in India is slowing. It is expected that in 2021, they're going to conduct the next census. 2021, it is expected that it will grow even lesser. Okay. So population between 2001 and 2011 grew by 17%. And between 1991 to 2001, population grew by 21%. Okay. Density. What is the current density of population in India? Density is 382 persons per square kilometer. Current density as per 2011 census. As per 2011 census, density in India is 382. 382 people per square kilometer. In 2001, this was 325 persons per square kilometer. Okay. So from 325, we have now gone to 382 in 2011. Density of population. Sex ratio. Sex ratio. Currently, as per 2011 census, it is 943 females per 1,000 males. 943 females per 1,000 males. In 2001, it was 933. In 2001, it was 933. So this is also a very important trend. Sex ratio in India has improved in the past 10 years. In India, sex ratio has improved in the past 10 years. From 933 in 2001 to 943 in 2011. So sex ratio in India has improved. Now, what part of the world has the highest sex ratio? Highest sex ratio in the world is in Eastern Europe. In the world, highest sex ratio in the world is in Eastern Europe. In Eastern Europe is the highest sex ratio in the world. What is the lowest? Lowest is West Asia. Lowest is West Asia. West Asia meaning Middle East. Highest sex ratio. Oh, sorry, there was some power fluctuation. Let's continue. Uh, Eastern Europe has highest. Eastern Europe has highest sex ratio, and West Asia. West Asia meaning Middle East countries. Middle East countries have least sex ratio. Okay. So what are the top states of India by population? Top states of India by population. UP is highest. Second is Maharashtra. Third, Bihar. Fourth, West Bengal. Most populous states of India by population. Most populous states of India: UP, then Maharashtra, then Bihar, then West Bengal. Okay. And you will find questions where like these states will be given and you have to write the right order, correct order. Okay. And you might get confused. Maharashtra, Bihar, West Bengal, what's the order? So it's Maharashtra greater than Bihar greater than West Bengal. What are the least populous? What is the least populous? Okay. Least populous is Lakshadweep. Lakshadweep. Then you have Daman and Diu. And Dadra Nagar Haveli. Then Andaman Nicobar and Sikkim. Lakshadweep, Daman and Diu, Dadra and Nagar Haveli, Andaman Nicobar and Sikkim. Highest population, UT is Delhi, obviously. Obviously, UT with highest population is Delhi. Densest state, highest population density in India is Bihar. Highest population density in India is Bihar. Okay. Next are the criteria. What are the criteria for census town? Census town, what are the criteria that are used? So first is that population should at least be 5,000. What are the criteria to be classified as a census town? First is population. Minimum population has to be 5,000. Second, at least 75% of population. At least 75% of population should have non-agricultural employment. Minimum population of 5,000. Second, at least 75% of the population should be involved in non-agricultural employment. At least 75% of population should be involved in non-agricultural employment. Third, Actually, no, only these two. Only these two criteria are important. Others you can name. Yeah. Minimum population 5,000. Second, 75% population in non-agricultural employment. There's a technical term known as conurbation. I'll send the spelling. The term in urban development known as conurbation. So just in general, you should be aware that such a term exists. This means a large area of urban development. This means a large area of urban development resulting from the merging of separate towns or cities. Conurbation is a large area of urban development resulting from the merging of separate towns or cities. So, for example, even Greater Hyderabad is a conurbation. Why? Because it's the merging of Hyderabad, of Secunderabad, of all the surrounding villages of like Gachibowli and all used to be villages which have now been merged into the city. Okay. So conurbation. Conurbation is the merging of separate towns or cities. Another related term is megalopolis or megacities. So megalopolis or megacities. So this is a super metropolitan region. Super metropolitan region, which is a combination of conurbations. Combination of conurbations. Okay. So like Tokyo is a mega city, which combines lots of previous conurbations, previous regions, previous cities, and becomes this huge area. Okay. Then there are two related topics of physiological density and agricultural density. Physiological density and agricultural density. I'll send the formula to you. Okay, so physiological density is total population divided by net cultivable area. Physiological density, total population divided by net cultivable area. Then you have agricultural density. Agricultural density is just the agricultural population divided by net cultivable area. Okay. These are basically different versions of population density. Like population density is total population by just total area of the country. If you're looking only at cultivable area, it becomes physiological density. If you're looking at agricultural population only, it becomes agricultural density. Okay. So next in human geography, particularly for India, is coal. We look at some energy sources. We look at energy sources, first of which is coal. Energy source of India, first of which is coal. Okay. So Indian coal is known for having high ash content. Indian coal is known for having high ash content. Okay. What is the reason for high ash content? The reason generally given for high ash content is the drift theory of formation. Drift theory. Because Indian coal has been formed via drift. Remember physical geography? There's a section about how Indian continent has drifted towards the main Asian continent, leading to formation of Himalayas. So because of that, Indian coal is said to have high ash content. For in situ formation of coal, there is generally low ash content. In situ meaning in one place. Opposite of drift theory of formation of coal is the in situ theory of formation. I'll send the spelling. Is the in situ theory of formation. In situ, it is said to have low ash content. In situ, it is said to have low ash content. Indian coal also has low calorific value. Low calorific value. Low calorific value meaning low energy. Per kilo of coal burnt, energy generated is less. Per kilo of coal burnt, energy generated is less. Next is sulfur content. Sulfur content in Indian coal is generally lower than coal from other countries. Sulfur content in Indian coal is generally lower than coal from other countries. The exception to this is lignite. The exception to this is lignite, which has higher sulfur content. The exception to this is lignite, which has higher sulfur content. The figure, not very important, but you can just like write it down to know it, is Indian coal sulfur content is 0.7%. 0.7%. Okay. Indian coal also has what is known as a high ash fusion temperature. High ash fusion temperature of 1500 degrees. High ash fusion temperature. Ash fusion temperature is basically an indication of the melting behavior of fuel ash. Okay. Ash fusion temperatures are characteristic of the melting behavior of fuel ash. Generally, low ash fusion temperature is preferred because it will mean that the ash will melt at a lower temperature. It will become easier to dispose. Value is 1500 degrees Celsius. Okay. So we has high ash content, low sulfur content, and high ash fusion temperature. Indian coal. Okay. There are two types of Indian coal. There are two types of Indian coal, which are based on geological sequences, geological ages. Geology, you know, is the study of rocks. So, and we discussed the ages part. Okay. So there are two types of Indian coal. 90% of Indian coal is Gondwana coal. 90% of coal production in India is Gondwana coal. Gondwana coal. Okay. Gondwana coal is known for having high carbon content. Gondwana coal is known for having high carbon content. Okay. And generally, high carbon content is accompanied by low moisture content. If the carbon content in coal increases, the moisture content in the coal decreases. If the carbon content in the coal increases, then the moisture content in the coal decreases. When carbon content increases, moisture content decreases. Okay. Based on quality, coal is generally classified into anthracite, bituminous, and lignite. This you must be aware. Okay. Based on quality of coal. So based on quality, anthracite Wait, sorry. Gondwana and Tertiary. Okay. The two geological ages are Gondwana and Tertiary. Gondwana is most of the production in India. Most of the production in India is Gondwana. Gondwana is generally bituminous and anthracite. Bituminous and anthracite comes under Gondwana. And in India, mostly it's bituminous. And Gondwana is known for having higher carbon content. Opposite of Gondwana is tertiary deposit. Opposite of Gondwana is tertiary deposit. Okay. This is Gondwana and tertiary are classifications based on geology. Gondwana and tertiary are classifications based on geology. Okay. The second type of classification is based on quality. Based on quality. Quality meaning basically on carbon content, because higher the carbon content, higher the quality. Second type of classification is based on carbon content. Okay. On carbon content, we have anthracite. Anthracite is the highest quality. Where is anthracite found in India? It is found in Jammu Kashmir, only in Jammu Kashmir. Anthracite coal in India. I'll send the spelling. Anthracite coal in India is only found in Jammu Kashmir. Anthracite coal in India is only found in Jammu Kashmir. Second highest quality is bituminous. Second highest quality is bituminous. Spelling I'll send. No, anthracite has highest carbon content. Anthracite is highest quality. Anthracite is highest quality, and this highest quality coal is found in Jammu Kashmir, only in Jammu Kashmir. Second highest is bituminous. Bituminous coal is found in Jharkhand, West Bengal, Odisha, Chhattisgarh, Madhya Pradesh. I'll repeat. Basically, that eastern belt of India, bituminous coal is found. Jharkhand, West Bengal, Odisha, Chhattisgarh, Madhya Pradesh. Jharkhand, West Bengal, Odisha, Chhattisgarh, and Madhya Pradesh. This is bituminous coal. Bituminous coal is second highest quality. Next is lignite. Lignite. Lignite is also known as brown coal. Lignite is also known as brown coal. This is found in coastal areas of Tamil Nadu, Pondicherry, Gujarat. Coastal areas of Tamil Nadu, Pondicherry, Gujarat is where lignite is found. Okay. In this, there's an important place. Important place is Neyveli. Neyveli in Tamil Nadu. Like Neyveli lignite plant is also quite famous. Neyveli. Neyveli in Tamil Nadu. Neyveli in Tamil Nadu is famous for lignite production. Neyveli in Tamil Nadu is famous for lignite production. Least quality is peat. We are not focusing too much on peat. Okay, least quality is peat. We are not focusing too much on peat. 2016, what were the coal production trends? In 2016, what were the coal production trends? So China is the largest producer of coal. China is the largest producer of coal in the world. Okay. Almost 45%. Almost 45% of the world's coal. In the entire world, 45% of that coal is produced by China. India is also a very large producer of coal. India produces almost 10%. India is also a very large producer. If I'm not mistaken, India is the second largest producer. I think it is the second largest producer, but please verify once. India is 10% of world's coal production. I think it is second largest producer of coal. Okay, and at 10% of coal, it is much higher than the production of US, much higher than Australia. Okay, India is 10%. What about coal imports? Coal imports, India is the third largest. Then China, then Japan, then India, then Korea. China, Japan, India, Korea. Okay. Then just some locations in the world. There are some locations in the world which are famous for coal production. Just remember them. Like in Europe, you have Kuznetsk. In Russia, Kuznetsk region. Kuznets, also known as coal basin in Russia. In China, you have Shanxi. Okay. Kuznetsk region in Russia. In China, you have Shanxi. In North America, in USA, you have Pennsylvania. Pennsylvania. Yeah. Okay. Yeah. This is enough. Like these are regions famous for coal production in the world. Next energy mineral we look at is petroleum. Next we look at petroleum. Petroleum. First is classification of petroleum is done into sweet crude and sour crude. Sweet crude and sour crude. Sweet crude and sour crude. Okay, if you want, they've asked about India's famous coal producing regions. I have the names. I just thought it will be too much detail. Fine, I'll send it. I'll send it. Just make a note if you want. Damodar Valley, Raniganj, Bokaro, Jharia, and Singareni. These are the important coal producing regions of India. Damodar Valley, Raniganj, Bokaro, Jharia, and Singareni. These are the important coal producing regions of India. Coal producing regions of India: Damodar Valley, Raniganj, Bokaro, and Singareni. So let me change mic. Okay. Next, petroleum. Petroleum, what is the classification? What is the classification of petroleum? Petroleum is classified into crude, sweet crude and sour crude. Sweet crude and sour crude. Sweet crude contains less amount of sulfur. Sweet crude contains less amount of sulfur. So it contains less than 0.5%. Sweet crude contains less sulfur, meaning it contains less than 0.5% of sulfur. It also requires less energy to be extracted. Requires less energy to be extracted. And it has less impurities. So sweet crude is just best for everything. Low pollution, low sulfur, so less sulfur oxides, less energy for extraction, also leads to higher production because of lower impurities. Okay, so sweet crude is just the best on all fronts. Iraq is the biggest producer of sweet crude. Iraq is the biggest producer of sweet crude. The other regions that also have sweet crude are West Texas, North Sea, Appalachian. Okay, so you have Appalachian region, West Texas region, North Sea region. These are the other regions in the world which are also known for the sweet crude production. Appalachian region, West Texas, and North Sea. These regions are also well known for the production, sweet crude production. Next is sour crude. Next is sour crude. Spelling of what? Okay, I'll send spelling of Appalachian. Appalachian region is in the US. It is known for its mineral production. Appalachian is known for its mineral production. It's in the US. Next is sour crude. Okay. Like sweet and sour, no? Sweet, opposite of sweet is sour. Okay, so sour crude. Sour crude has high amounts of sulfur. Sour crude has higher amounts of sulfur. It also has high levels of impurities. Like it can go as high as 1.7, 1.8% sulfur. Sour crude has high amounts of sulfur and high amounts of impurities. It can go as high as 1.7, 1.8% of sulfur. Venezuela is the largest producer. Venezuela is the largest producer. Venezuela is the largest producer. And generally, high amounts of sour crude are found in the Gulf of Mexico and South America region. Gulf of Mexico and South America region. Gulf of Mexico and South America region are the largest. Overall, if you were to combine sour and sweet crude and look at it generally largest proven crude reserves is Venezuela and Saudi Arabia is second. Largest crude oil reserves generally without classifying, just generally largest crude oil reserves. Largest crude oil reserves in the world are in Venezuela. Saudi Arabia second. In India, crude oil is mostly found in the offshore deposits. What are these offshore deposits? Generally are in Mumbai, also known as Mumbai High. Largest crude oil reserves are in Telugulo offshore ante onshore enti onshore idi coast pakkana unna kaani land మీద ఉంటాయి. Offshore ante sea లో ఉన్నప్పుడు. Offshore crude oil reserves ante sea లోపలికి వెళ్ళి sea పైన rig అంతా కన్స్ట్రక్ట్ చేస్తారు. ఆ rig కన్స్ట్రక్ట్ చేసి ఆ rig ద్వారా డ్రిల్ చేస్తారు లోపలికి డ్రిగ్ చేసి ఆయిల్ తీస్తారు. దట్ ఈస్ ఆఫ్షోర్. సో వెస్టర్న్ ఆఫ్షోర్ అంటే జనరలీ ముంబై రీజన్ ముంబై హై అనేది పెద్ద క్రూడ్ ఆయిల్ ప్లాంట్ ఉంది, రిగ్ ఉంది. ఓకే, అనదర్ ఇంపార్టెంట్ ఏరియా ఇస్ కృష్ణా గోదావరి బేసిన్. and Assam. Krishna Godavari Basin and Assam. Okay. So natural gas. Natural gas. Natural gas. India's largest reserves of natural gas are located on eastern offshore. India's largest reserves of natural gas are located in eastern offshore. And second highest is western offshore. India's largest reserves are located in eastern offshore, and second highest is western offshore. Globally largest producer of natural gas is Qatar. Largest producer of natural gas is Qatar. Okay. Then related to natural gas is a technical type of natural gas known as coal bed methane. Coal bed methane. One sec, let me just verify natural gas. I think Qatar has highest density. Yeah, Qatar has highest density. Qatar has highest density of natural gas, but largest producer is US. So I just make that change, please. Largest producer of natural gas is US. US is the largest producer. Second, Russia. Third, Iran. Fourth, Qatar. Okay. So just US, then Russia, then Iran, then Qatar. US, then Russia, then Iran, then Qatar. Qatar is the largest producer of liquefied natural gas. Liquefied natural gas. Qatar is the world's largest producer of liquefied natural gas, as well as the world's largest exporter of liquefied natural gas. Okay, USA, then Russia, then Iran, and then Qatar. These are the four largest producers of natural gas in the world. Qatar is the largest producer of liquefied natural gas. Okay. So now let's look at coal bed methane. Coal bed methane is a technical type of coal bed methane. So coal bed methane is considered an unconventional form of natural gas. Coal bed methane is considered an unconventional form of natural gas. By absorption, it is stored within the coal. Coal bed methane is stored within the coal. It is a form of natural gas which is stored within the coal by absorption. Okay. Coal bed methane has gas stored within the coal by absorption. Coal bed methane coal is considered important. Coal bed methane is considered important because it is said to produce sweet gas. Sweet gas. Sweet gas again meaning less sulfur. Sweet gas. Coal bed methane produces sweet gas. Sweet gas meaning with less sulfur. Less sulfur. It also has less heavy hydrocarbons. It also has less heavy hydrocarbons. For those who have done chemistry in 11th, 12th, I'll just explain what this means. For those who don't understand what this means, it's fine. Okay, not needed. Basically, coal bed, like when you have natural gas, you have all these compounds like methane, ethane, propane, butane, all these compounds. Coal bed methane is considered valuable because it has less heavy compounds. It has less heavy meaning it has methane, it has ethane. Heavier hydrocarbons would be butane, propane. These would become heavier hydrocarbons. But the heavier hydrocarbons are not there. The lighter, more energy efficient, more calorific hydrocarbons like methane and ethane are there in coal bed methane. Primarily methane, which is why it's very important. Okay. If you don't understand what this statement means, it's fine. Those who understand it, understand it. Okay. ONGC. Yeah, coal bed methane policy is also news, which is why coal bed methane is important this year. Coal bed methane policy is basically how, like, setting standards and regulations for how to extract coal bed methane. Okay. It is setting of energy standards for how to extract coal bed methane so that it is done without harming the environment, how to price it, all those things. In science and tech, in fact, ONGC and TERI is Tata Energy Research Institute. ONGC and TERI have designed the mechanism of using microorganisms to enhance coal bed methane production. Just a fact from current affairs. ONGC and TERI have designed a mechanism for production, for enhancing the production of coal bed methane using microorganisms. ONGC and TERI have designed a mechanism to enhance production of coal bed methane using microorganisms. Next is also a subtype, which is shale gas. Shale gas. Shale gas is a type of natural gas produced from shale, which is a sedimentary rock. Shale is a sedimentary rock, and within that you have something known as shale gas. Okay, which is something known as shale gas. In shale gas, China has the world's largest reserves. In shale gas, China has the world's largest reserves. USA is second. In shale gas, China has the world's largest reserves, and then USA is second. In India, Krishna Godavari Basin. In India, Krishna Godavari Basin is said to have the highest shale gas reserves. In India, the Krishna Godavari Basin is said to have the highest shale gas reserves. In India, Krishna Godavari Basin is said to have the highest shale gas reserves. Those who want to write down can write down, but I'll just quickly explain how shale gas extraction takes place in case there's some conceptual question related to this. Okay, shale gas extraction, what happens is you'll have shale. Shale is a sedimentary rock. Sedimentary rocks, what is the property of them? That they occur in layers. Okay, sedimentary rocks occur in layers. So where is the shale natural gas stored? This gas is stored between the layers. Between the layers of these sedimentary rocks, the gas will be stored. Now, if the gas is stored between the layers, how do you extract it? The way extraction takes place is you drill holes into the rocks. You drill holes into the rocks to make this gas escape. And the way they make the gas escape is they pump fluid into the gaps, into the layers, into the gaps between the layers. So that if you pump fluid inside, the gas will come out. Like that's how production of shale gas takes place. Okay. Just if in case there's some conceptual question and so on, you can answer. And why is shale gas considered environmentally damaging? Because when you are pumping this liquid like water or something inside, the water also becomes contaminated with these hydrocarbons. Okay, there are some cases like US is one of the US is second largest producer of shale gas. There are some cases where water, like public water supply, has started catching fire because the water supply has these gases within it. Okay, so that is the environmental shortcoming. That is the environmental shortcoming. Next in energy is hydropower. In energy, next is hydropower. In hydropower, there's a concept known as command area. Hydropower, there's a concept known as command area. So command area is the area which can be economically irrigated from an irrigation system. Command area command area command area is the area which can be economically irrigated from an irrigation system. So for example, for a dam, the area which benefits from the dam, the area which gets benefits like irrigation water, electricity, all these become the command area of a dam. Command area of a dam is the area which economically benefits from the dam. Okay. Next, the largest dam in India. Largest dam in India is Indira Sagar Dam on Narmada. On Narmada, largest dam in India is that Indira Sagar Dam. I think they changed the name recently, but basically the Narmada Dam. Narmada Dam is the largest dam in India. Okay. Second largest is Krishna Raja Sagar Dam. Krishna Raja Sagar Dam on Kaveri. Krishna Raja Sagar Dam. Krishna Raja Sagar Dam on Kaveri is the second largest dam in India. What is the potential for hydropower in India? River wise, let's look at it river wise. River wise, what is the potential for hydropower in India? Highest is Brahmaputra. Highest is Brahmaputra. Second highest is Indus. And third is Ganga. Potential for hydropower production. Highest is Brahmaputra, then Indus, then Ganga. Okay. Next, uranium. Next, uranium. So uranium in India production is quite modest. It is not very high. Uranium in India production is not very high. In India, the uranium deposits occur in Dharwar rocks. Dharwar. I'll type out the spelling. In India, uranium production happens in Dharwar rocks. In India, uranium production happens in Dharwar rocks. Okay. And uranium ore is also found in the Singhbum copper belt. In the Singhbum copper belt. In Jharkhand. Okay. There are some other details. I'll just narrate it out. If you want to write it, write it. Okay. So highest uranium production is in Andhra Pradesh, followed by Jharkhand and Meghalaya, which are the top states with uranium reserves. Uranium reserves, Andhra Pradesh, then Jharkhand, then Meghalaya. In Rajasthan, uranium is found in districts of Udaipur, Alwar, and Jhunjhunu. In Chhattisgarh, it is found in Durg district. In Maharashtra, it is found in Bhandara district. Okay. So why are domestic uranium reserves important for India? Domestic uranium reserves are important because it is used for its weapons program. For weapons program, India uses its own reserves. India does not import any uranium for weapons. All India's nuclear weapons use domestic uranium. All of India's uranium uses domestic. All of India's weapons use domestic uranium. List of in that entire list, the important fact is only one. Only one fact is important, which is Andhra Pradesh has highest uranium reserves in India, followed by Jharkhand, followed by Meghalaya. These are the three highest. Andhra Pradesh, then Jharkhand, then Meghalaya are the highest reserves of uranium. What about India's nuclear reactors then? India's nuclear power plants. India's nuclear power plants, uranium is largely imported. And it is imported from Kazakhstan, Canada, and Russia. India's uranium imports. India's uranium imports are from Kazakhstan, Canada, and Russia. India's uranium imports are from Kazakhstan, Canada, and Russia. Kazakhstan, Canada, and Russia. What are the nuclear power plants in India? Tarapur. Tarapur in Maharashtra. Tarapur is in Maharashtra. Tarapur in Maharashtra. Rajasthan has a nuclear plant known as Rawat Bhatta. That's understanding. Rajasthan has Rawat Bhatta. Rajasthan, Rawat Bhatta. Then Kudankulam. Kudankulam in Tamil Nadu. I think, I'm not certain, but I think Kudankulam is the largest so far in India. So far in India, I think Kudankulam is the largest. Kudankulam in Tamil Nadu. Tarapur, Maharashtra, Rawat Bhatta, Rajasthan, Kudankulam, Tamil Nadu. Then Kaiga in Karnataka. Kaiga in Karnataka. Kaiga in Karnataka. Then Kakrapar in Gujarat. I'll send the spelling. Kakrapar in Gujarat. Kaiga in Karnataka, Kakrapar in Gujarat. Then again in Tamil Nadu, Kalpakam. Again in Tamil Nadu, Kalpakam. Okay. And Uttar Pradesh, Narora. Narora in UP. Okay, these are primarily India's nuclear power plants. Next you have thorium. Thorium. Thorium is 3.5 times. Thorium is 3.5 times more common than uranium. Thorium is 3.5 times more common than uranium. Okay. India and Australia are believed to possess 25% of world's thorium reserves. Thorium is 3.5 times more common than uranium. And India and Australia are said to possess 25% of world's thorium reserves. But till now, we do not have the technology to make nuclear power plants using thorium. But research is ongoing. Research is ongoing to try and make power plants which can use thorium. Okay. Theoretically, the way thorium would be used in nuclear power plants is thorium would be converted to uranium 233. Conversion of thorium into uranium 233. Uranium 233 so that it can be used to produce nuclear power. Currently, it is not happening, but that's why thorium is said to be fuel of the future. Thorium is also said to be fuel of the future. In India, where is thorium found? In India, thorium is found in the monazite and ilmenite sands of Kerala and Tamil Nadu. Monazite and ilmenite are said to be rich in monazite and ilmenite are said to be rich in thorium. Monazite and ilmenite are said to be rich in thorium. Okay. And these sands are found in Kerala and Tamil Nadu. Kerala and Tamil Nadu. The world's richest monazite deposits. World's richest monazite deposits are found in Palakkad and Kollam districts of Kerala. In Palakkad and Kollam districts of Kerala. World's richest monazite deposits are found in Palakkad and Kollam districts of Kerala. Palakkad and Kollam districts of Kerala. Okay, world's richest. Some other deposits of monazite in India are near Visakhapatnam and near Odisha. Near Visakhapatnam and near Odisha. Also, you have thorium deposits through monazite deposits. What are the advantages of thorium over uranium? What are the advantages of thorium over uranium? First is fuel performance. Fuel performance is higher. First is fuel performance is higher. Fuel performance is higher. Second is abundance. Abundance. Thorium abundance is much higher, obviously. Thorium abundance is much higher. Okay. So I'm thinking with this, energy is complete, population and energy are complete. Next, there is mining, minerals, there is agriculture. So, okay, I'm thinking we'll do that. I'll find out. Do you have class on Sunday? Yes or no? Do you generally have, do you want to keep, what is this? Okay. Okay, fine. Then Monday we'll do the rest. Monday we'll start with mining and minerals. Monday we'll start with mining and minerals, or I'll talk to CSP and find out. Okay. We start with mining and minerals. Mining and minerals basically mica, steel, iron. What is the production trend? We'll do it in a similar fashion. Okay. And yeah, I'll also take questions. I'll also like find some questions related to these concepts, so we can also do questions alongside. Tomorrow class, if it's possible or no, let me check with CSB. Let them find out and tell me if it's needed, not needed. But yeah, as long as you're finding it useful, we'll see. Okay. Otherwise, Monday we'll meet. Monday generally anyway we're supposed to meet. Monday we'll do mining and minerals. Okay. I'll also find some questions and we'll do those questions in class.